So we're only looking at the first part of it. It says locate the centroid. Well, first of all, they're asking us for the centroid, but how do you know that you really are looking for the centroid? How do you know? They're giving you area. So you know you're dealing with centroids, two-dimensional centroid of area. So how many pieces do you want to divide this up into? 5? So let's see. This triangle, this rectangle, this triangle. How about only 4? What do you think? We do 4?
That's great.
This bottom piece, and then 2 triangles and a rectangle? Kyle, is that all right, instead of 5? Okay, so let's look at the problem then. It's on the next page. I didn't do a good job on estimating how much room I had. So I should have done 4 columns, because that's what we've been doing, but I ran out of room, so I just wrote the 4th column on the bottom. And it was terrible. I should have done 4 columns, because what happens is, when I did this, I made 3 math mistakes. A math mistake 3 times. If I did a table, I wouldn't have. Okay, so what wasn't 3 math mistakes, but because I did this, I had to check all 3 of them at the same time, because I made it math, I had 2, I got the wrong answer, and when I went back to check this, I had to put this whole damn thing in the calculator again. Had it been in a column, I would have been able to check each one individually. Then I got the wrong answer again. And then I had to go back again, so I was so pissed that I didn't do my 4th column. So I will, in the future, have changed this to landscape and not, okay, so to have more room. So, first column represents the section, and I divided it up into 4 sections. Second column represents the critical component that you're dealing with, area. Third represents the distances. And then the 4th should have been what? Jill, what should my 4th column have been? Right, so critical component, so it should have been the area times the distance. And I would have had each one of these in here. And then I summed up the area, I would have summed up the critical component times the distance. And then I got the answer. How is everyone? Andrew?
Where does the phrase critical component come from?
It's my own, it's me. I mean, I'm sorry. I'm glad you asked. I don't think you're going to find it in the textbook. So it's, what would you call it? Like for center of mass, this is what you're dealing with. With center of gravity, this is what you're dealing with. Centroid and 2D, you're dealing with this. What would you call these things? I call them critical component, but I don't know. What would you call it?
I like
The important item?
the important item.
What?
Object of interest.
Object of interest? What else would you call it? Peter?
BII.
BII.
Very important item.
Very important item. So you can make it up, whatever you want, whatever, it's the important thing.
The nexus.
The what? Okay, so is everybody okay with this? Okay, so now, we have 5 minutes left, so I just want to talk a little bit about the moment of inertia things. So, go to this page. It's going to be really hard to see it from up here. It's impossible, actually.
There we go.
So don't look up here, I guess look in here. Here, it's this one. Second moment of area. Scott, does everybody have it?
Oh.
Yeah, it's in the middle. Should have numbered it. So these expressions, so the letter capital I represents moment of inertia. Just like M, we use capital M means moment. Capital I means moment of inertia. Okay? So, if I had calculated this really right here is a moment, right? Even though it's a weird moment, it's a moment, I would use capital M. But this, I use I, and this I use I. So this is second moment of mass, second moment of inertia. These values have been derived for you, which means we could, actually, in the pack, I didn't copy it in here, but in the packet online, I show you how they got every single one of these equations. Not every single one of them, but a number of them, by integration. But we don't have to do integration. We have these for us, and that's all we're going to use are these numbers. So let's look at the first one. There's a picture there of a rectangle. And take a look at the axes. So BH cubed over 12 is a moment of inertia. But it's a moment of inertia of which axes? X. And where is X going? Where is